So now we're going to look at some equations as relations. An equation in two variables, your solution is going to be a set of ordered pairs that always make it true. So if you're given an example of an equation, y equals 2x plus 3, and you're given what's called a replacement set, these are the answers that we're going to try, or these are the number of ordered pairs we're going to try. They might not all be answers or make it true. So if they're true, they're part of the solution. So this does require some arithmetic, but you're just going to take y equal 2x plus 3. Remember, this is the x coordinate, this is a y coordinate. So I'm going to replace the y with a negative 1. I'm going to replace the x with a negative 2, and I'm going to do the math. So negative 2 times 2 is negative 4, plus 3 would be negative 1. Does negative 1 equal negative 1? Yes. So part of my solution set would be the ordered pair negative 2, negative 1, because it made it true. So now you just take the next one. 3 equals 2 times negative 1, negative 1, is that right? Oh yeah, plus 3. 2 times negative 1 is negative 2, plus 3 would be 1. Does 3 equal 1? No, so that's not a solution. So now I'm going to try 0, 4. 4 is y equals 2 times, what's my x? 0 plus 3. 2 times 0 is 0. 0 plus 3 would be 4. So does 4 equal 3? No. So now I'm going to try the ordered pair 3, 9. So y is 9 equals 2 times x is 3 plus 3. 2 times 3 is 6. 6 plus 3 is 9. I get 9 equals 9. So yes, that is a solution. So the ordered pair 3, 9 goes in my solution. So yes, you do have to do some arithmetic here. You just got to stick them in and try them. Remember, the first coordinate is the x, the second one is the y. And if they make it true, if you get a true sentence in the end, 9 equals 9, yes. 4 does not equal 3, so that's a no. So that's how you tell if it's a solution or not. Again, we're going to have several different types of problems today. Solve if the domain, which remember is the first coordinate. Now, here when you do have other letters of the alphabet instead of x and y, when you put them in alphabetical order, whatever the first letter of the alphabet is would represent the x. So in this case, this is going to represent the x. You can do this two ways. I like to just make a table. In this case, I guess it's going to be an A-B table. So these would be values that I'm going to put in for A. So negative 3, negative 1, 0, 2, and 4. Now the other way to do it would be to write your answer as a set of ordered pairs, with negative 3 being your first coordinate and so on, negative 1 being your first, and you're going to find the second. So I don't care if you just want to write it in the table, it's easier for me, I think. And I think we'll be able to do most of this math in our head. If you need to write out some problems, go ahead and write them out, but if you can do it in your head, that's fine with me. So A is going to become, so we're going to get B equals, I'll write the first one out for us, negative 3 plus 5. Negative 3 plus 5 is 2, so B would be 2 when A is negative 3. If we put a negative 1 in there, we're going to get 4. If we put a 0, 0 plus 5 is 5. If we 2, you're going to get 7. If you put a 4 in there, you're going to get a 9. So this is how your answer can look, or if you want to write it like this, it would be a set of ordered pairs. You'd have to write all of them down and then close your set. So if you make a table, I think that'll probably be a little easier for you. Okay, next it says solve for y, because when we do these, we want to have the y by itself a lot. So this is going to be a very important skill to have. We've already worked on this a little bit, so this is kind of a refresher. But remember, you're trying to get the y by itself, so you have to use your rules for solving equations. So it's being multiplied by 3, so the opposite of multiply by 3 is divide by 3. Show that we do it on each side, and we get y equals x plus 6 over 3. There is another way to write this. As long as 3 doesn't go into both of them, you can leave it like this. If this were 3x, you would have to go ahead and divide. Or another way to write this would be x over 3, and then go ahead and divide the 6 by 3 plus 2. So you can get either answer there. So if you want to stop with this first answer, that's fine with me, as long as it doesn't go into both of them. But if both numbers are divisible, you must simplify. So again, we're trying to get the y by itself, so I need to get rid of my 4x, so I'm going to subtract 4x from each side. I get 2y. Now later on we're going to have the x term first. It doesn't really matter now, so you can either put 10 minus 4x or you can put negative 4x plus 10. For this time it doesn't matter. Later on we will be having to put the x first, so if you want to get in the habit of doing that, you can. So now we would need to divide by 2. Now here both numbers are divisible by 2, so I cannot leave this as my answer. 10 divided by 2 is 5. 4x divided by 2 is 2x. And again, if you write negative 2x plus 5, that would be the same. Problem 5, I want to get my y by itself, so I need to subtract the 2x from each side. This time I'll do it as putting the 2x first, so it would be negative 2x plus 8. Now again, if you want to write 8 minus 2x, not a problem. Divide by 3, so I get y. Does 3 go into any of these? No, it does not, so just negative 2x plus 8 all over 3, or 8 minus 2x. So it doesn't really matter which way you write. So you're solving for y, getting the y by itself. And now here's why we did that. So we're going to use that in this problem. Before I start and make my xy table, I want to get my y by itself. So I'm going to divide everything by 2. So I get y equals, here they are divisible by 2, negative 1x, and 12 divided by 2 would be plus 6. So now again, I'm going to make an xy table. If you want to write it as a set of ordered pairs, you can. So my x's are negative 3, negative 1, 0, and 2. So negative 1 times negative 3 plus 6. Negative times negative would be positive 3. 3 plus 6 is 9. Now if I put a negative 1 in, again, if you can do this in your head, negative 1 times negative 1 would be positive 1 plus 6 would give me a 7. Put a 0 in, negative 1 times 0 is 0, plus 6 would be 6. Put a 2 in, negative 1 times 2 would be negative 2, so negative 2 plus 6 would be 4. So there it is in a table form, or if you want to write it as a set of ordered pairs, you may. To me, table's easier, but that's up to you. All right, this one it says solve and graph given the domain. So we're adding a step to it. The solving is the same thing. First check, yes, the y is by itself, so we don't have to do that extra step. So we make our table, x, y. We know our x values here. Negative 3, negative 1, 0, 1, and 2. So you're going to put those in. If I put a 3 in, again, sometimes it helps you write the first 1 or 2 down, then you can start doing it in your head. 3 times negative 3 is negative 9 minus 1, remember it becomes plus negative, would give me negative 10. Going into my y there. If I put a negative 1 in, 3 times negative 1 is negative 3, minus 1 would be negative 4. If I put a 0 in, 3 times 0 is 0, minus 1 would be negative 1. Put a 1 in, 3 times 1 is 3, 3 minus 1 is 2. Put a 2 in, 3 times 2 is 6, minus 1 is 5. So I now need to graph these ordered pairs, it said. So I do have a graph. I'm not sure it goes out to negative 10, so we can approximate where that is on the next page. So negative 3, negative 10. So negative 3, 1, 2, 3, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere down here we can just approximate. Negative 1, negative 4 would be right here. 0, negative 1, 1, 2, right 1, up 2, and 2, 5, right 2, up 5. And again, you don't have to label each individual point. That would be what you need for that.